Hello, good morning. So let us start. Yesterday I told you that this Laplace wave function, Laplace equation will give you the potential, and potential it can be at any point xy, means it is the 2D equation. Okay. So let us solve one question for potential at in any region of two-dimensional is given as this is a 2D potential given. Okay. So if I check, this point is 0, 0, this point is A0, this point will be AB, and this point will be 0, B. These are the points. And the initial condition of potential are like that. Whenever it touch to the boundary, at boundary the value is 0. So these are the boundary. At this boundary, U is equal to 0. Here also, at this boundary, U is equal to 0. Here also, U is equal to 0. Here also, U equal to 0. Okay. And U is, it can be defined at any point inside this region. This is like that. So find UXY. This is the question. Okay. Your X is lying between 0 to A and Y is lying between 0 to B. These are the things have been given. Now, so how we can solve it? So first of all, we will define the boundary condition. So boundary conditions are, number one, U, X, Y. See here, at X equal to 0, but Y can be any value. So what is that? It means that is this line. At X equal to 0 and Y can be any value, means I am talking about this line. Understood? So at this line U is equal to 0. So how we can represent it? It is U0, but Y can be any value, that will be equal to 0. So this is your boundary condition. And now how we solve our problem? We always solve our problem. We can put U equal to X into Y here. Okay, pure function of X, pure function of Y, means UXY can be put XX, YY. This is our method how we solve partial differential equation. So here it will become now X, because this X is 0, into Y, Y can be any value. This is equal to 0. So this implies X0 equal to 0. So this will be used as first boundary condition. Number second, similarly, U at X, A, U X, means suppose I am taking this line. At this line also it is 0. Now at this line, value of Y is B and X can be anything between 0 to A. So you can say U X, but Y value is B. So that will also give you 0. So it means it is X, X, Y at B, that is equal to 0. So from here I will get variable value. I will not take, only constant value you have to take. So constant value is YB here. So the YB will be equal to 0. So this is your second condition. So like this we can define it. Note down this.
Done, sir.
Okay. Now, third condition I can write. Means third and fourth condition are like this. I can take this line. So at this line, your x value is a, y value can be anything. So means u x u a y will be the next condition. Now for this line y value is 0. So u x 0 also is a boundary condition. So these are the four boundary conditions. So number third, u a y. UAY with 0, so it will give you XA into YY is equal to 0. So this implies XA is equal to 0. So this is your third boundary condition. And in fourth, Y value is 0, na? X value can be any. Y value is 0 is also 0. So this will give you XX into Y0 is equal to 0. So this implies Y0 equal to 0. So this is equation number 4. Okay. So now we can use solution of Laplace equation. What is that? U xy is equal to C1 e to the power lambda 1 x plus C2 e to the power minus lambda x. It is not 1, it is only lambda x into a cos lambda y plus b sin lambda y. Okay, so this is the function yy and this is the function xx. So now you can apply boundary condition. Now from here xx is what? Xx is c1 e to the power lambda x plus c2 e to the power minus lambda x. So put x equal to 0. So x0 will become c1 plus c2. Okay. So but x0 is 0 as per boundary condition 1. So this implies c1 plus c2 equal to 0. It means c1 equal to minus c2. So that can be replaced. Hence xx will be c1 e to the power lambda x minus c1 e to the power minus lambda x. So c1 can be taken common. It will become e to the power lambda x minus e to the power minus lambda x. Okay, if I make here divide by 2 and multiply by 2, so what it will become? It will become 2 c1 into, this is a sine hyperbolic lambda x. But 2 c1 is a constant, so I will not keep 2 constant. So just keep it c into sine hyperbolic lambda x. So you can put here 2 c1 equal to c. Okay, so like this, my xx is c sine hyperbolic lambda x. So this much will be your xx. Note down this.
Sir.
Okay, so next condition is that here y is a cos lambda y plus b sin lambda y. Now in that you put at y equal to 0, means fourth condition will be applicable. So y0 equal to a into cos 0. Cos 0 is 1 plus b into 0. So this implies a is equal to y naught, and y naught already 0. So this implies a is equal to 0. Hence, so your y will be b sin lambda y. Okay, now again you apply one more boundary condition. What is that? This yb is equal to 0. Put y equal to b. So yb will be b sin lambda into b. Okay, so this yb is also 0. So this implies b sin b into lambda is equal to 0. Now b cannot be 0, otherwise your whole y function will be 0 and everything will be waste. Okay, everything will vanish. So it means sin b lambda is equal to 0, and that can be written as sin n pi. So by comparing on both sides, b lambda equal to n pi. So lambda equal to n pi by b. So this value you can put everywhere. So yy is, first of all, yy is bn, because now here n has been entered. So your coefficient also will be in term of series bn sin n pi by b into y. So this is your yy, and xx also you have find out. This is your xx. Okay, so both of them can be multiplied now. Now one more thing you can take, because here c is also a constant, so that will be multiplied with bn. So that is a different constant. That different constant can be given another name. Okay, so u xy will be equal to, now because it is in the term of series, so you can make it a series 0 to infinity. Now bn into c, that I can write some another constant, suppose it is kn, into x is sine hyperbolic n pi x by b, because lambda value I am putting, into this value. This value is sine n pi by b into y. Okay, so this is your final answer. Note down this. And you can mention here, we have put bn into c is equal to kn, new constant.
Yes, sir.
Okay. Now at x equal to a, so this is my equation. Suppose this equation is 5. So at x equal to a, now tell me, it will be a function of what? It will be a, because x has become constant now. If you put at x equal to a, so then uxy will be known as uay. So ultimately what is this? It is now from x side, it is constant. It is just only a function of y. It is only a function of y now, because a is constant, so that we can write as fy. Understood this thing? Means I am talking about this line. So at this line, because this x value is fixed, so this value will be known as, here if you go up and down on this line, so then you will get fy. So fy will be your function in place of uxy. Okay, so equation 5 becomes,
sir, but
yes,
x is equal to a is the third boundary condition, that is 0. So the third boundary condition is it will use 0 value. So you just mean that we just fix x, not like a, right?
Okay, understood. Okay, so what you take it, what we have taken there, boundary condition, we have taken a. Yes,
Yes, sir. We have to take another variable.
So you do one thing, in place of a, you take any between value. So in place of a, suppose what you take it, suppose m it is, m point. So then it will vary na. Here it is not 0, but x value is fixed, m. Okay. So I want to say that, means I want to say just only one line, one term I want to fix here. So just you put here m. So it is only a function of y, it is known as fy. So you take it as m. Okay. So now equation 5 will become now fy will be equal to, just in place of x you put m. So it will become summation n equal to 0 to infinity sine hyperbolic n pi m by b into sine n pi by b into y. So this is a pure function of y now. So how to find out this kn value? So using the Fourier method. So what you have to do, this term is only variable now. So this value will be multiplied on both sides. And integrate. And y value can go from, because this value is b, this value is 0. So y value can go from 0 to b. So left hand side will be integral 0 to b fy into sine n pi by b into y dy. Right hand side will be kn into sine n pi m by b will be constant. So it will be sine hyperbolic n pi m by b integral 0 to b. Now it will be sine square n pi y by b dy. And this term is always b by 2. Remember this. If you remember this type of integration, so it will be easy now. sine hyperbolic n pi m by b into b by 2. Okay, so kn you can find out easily now. So this implies kn will be 2 by b sine hyperbolic n pi m by b into integral 0 to b fx sine n pi y by b dy. So like this you can find the kn value. Okay, now what I am telling you, this formula you can remember directly. Why? Because this much labor you will not be required now. If you remember this formula directly in such cases, so kn value you will find out directly and you can put in the answer. That's it. Because fy will be given to you. Sorry, this is fy. Fy will be given to you in the problem. Then you can use it directly. Note down this.
So this f of y will be given in the question as bounded.
Yes, f of y will be given. Okay, so just I wanted to tell in some question. Suppose this is a question. For Laplace equation given fy equal to v naught equal to 5 volt. Okay. Find potential uxy. So this is the question. So here, so what you need to find out? Directly you need to find out the kn value. Because fy is given, so kn value will be twice divided by b sine hyperbolic n pi m by b into 0 to b fy. Fy is v naught or 5 volt, so that can be put afterwards. So just v naught I am putting, and v naught is constant, will come out. So only sine n pi y b dy, only this much you have to integrate. So what it will be? This whole term, I am not writing it, into, just integrate this, it will be cos n pi y by b divided by n pi by b.
For minus.
Yes. 0 to b. So this will be minus of 2 by b sine hyperbolic n pi m by b. Now b by n pi will come from here. This one, okay. Now you apply this, so it will be cos b. It will be cos n pi. Understood? And minus cos 0. So cos n pi will be minus 1 to the power n, and cos 0 is 1. Okay. If you multiply this minus inside, So what it will become? It will become, sorry, V naught also was there, no? So it will be this 2B. This B will also going up, na?
So we will cancel.
B. We will cancel. How?
In the denominator, no B will be.
Sorry. This is na. Okay, it will be cancelled. And n pi, it will become n square pi square. So 2B V naught by n square pi square m into sine, sorry, this is with hyperbolic. What are you doing?
Yes, sir.
But it will be cancelled. It will be cancelled. Okay. So it will be, sorry, 2 divided by n pi m. B is cancelled. So 2 V naught divided by n pi m sine hyperbolic n pi m by b into this minus will be multiplied inside, so it will become 1 minus 1 to the power n. Okay, so like this it can be. But how this m came? No, m will not be there, no?
M is not there, sir.
This is 2 V naught upon n pi sine hyperbolic this much into V naught. V naught. And V naught is equal to 5 volt. So that also you can put here. So it will become 10 V. That's it. So this is the value of Kn. Now you can put the value of Kn where? In your this equation here. But you want to find out this, na? So here you have to put. So you can get the complete equation by putting the value of Kn in 5. Hence, by substituting Kn in equation number 5, we get solution. Understood? So this you can do. Note down this. One more last method is left. So problems you can see, more problem you can see from the your assignments. Okay, from assignment you can solve. So one more method is left, so that method I will explain. So just it will take 5 to 10 minutes, and after that we will start Laplace. Note down this.
Different side.
So new method is for polar coordinate system. You can put the heading Laplace equation in polar coordinate system. Okay, so one way is that this is the basic definition of that. This is the steady state heat equation only. That will be converted to Laplace equation. We have seen this earlier. Okay, so now Laplace equation we have seen in MT also. So this is del square u equal to 0. But what is the meaning of del square here? Here you have to take two coordinate r and theta. And with that, this del square will be del to u by del r square plus 1 by r del u by del r and plus 1 by r square del to u by del theta square. So this is the complete equation of this del square if you open in this. Okay, or this can be written as in short form u r plus 1 by r u r plus 1 by r square u theta theta, that equal to 0. Okay, so now here what you have to do, this is my complete equation. I told you how to solve such type of problem. To solve it, put u r theta. Now because u is function of r and theta, so pure function of r, pure function of theta you have to take and multiply them. So this will be r into theta theta, like this. Or if you want to make it different, so you can take here phi function. Whatever, it is your choice. If you want to make it different, so just you can take, this is angle phi is function of theta, like this also you can say. Okay, now this you can put in main equation. So equation 1 becomes in this equation, if you put, so r is differentiated and phi is constant here, so it will become phi theta into r double dash, means this is double differentiation of r, plus next is 1 by r into, here also your phi is constant and r will be differentiated, so it will be phi r dash plus 1 by r square into, now this is double differentiation of phi, r will be constant here, so r into phi double dash is equal to, sorry, not double dash, it is double do, okay, it is with respect to theta na, okay, double dash, but its meaning is del 2 phi over del theta square, its meaning. Okay, so note down this. Now you can divide whole equation by this, because this is our method. Note down this.
That's it.
Okay. So differentiating this equation, from here you will get 1 by r double dash plus, here you will get 1 by r dash, and plus 1 by r square 1 by phi into phi double dash is equal to 0. Okay, now what you can do, this we can separate out, and this r square, because we want to make a pure function of phi, pure function of r. Okay, so we can take it on right hand side, so it will become 1 by r double dash plus 1 by r r dash equal to minus of 1 by phi double dash. Okay, this r square I will multiply this side, so it will become r square here and r square here, so this will be cut. Okay, only this much is left, and because it is pure function of r, here it is pure function of theta, so that can be given with some constant lambda square, say. Okay, so now what it will be, it will give me 2 ODE. We get 2 ordinary differential equation. One will be r square by r del 2r by del r square plus r by r del r by r, that is equal to lambda square. Now here you can make it, because you want the coefficient 1 here, so r by r square I will multiply to whole equation, so it will become del 2r by del r square plus r by capital R by r square I am multiplying, so again it will be 1 by r del r by del r equal to, or lambda square I can take left hand side, so it will become minus r by r lambda is equal to 0. So you can say that here del 2 by del r square plus 1 by r del by del r and minus r by r, not r by r, lambda by r into r is equal to 0. So this is a homogeneous second order differential equation. It will work as FD. So note down this quickly. But I think it will not solve it. Okay, one more thing we can check. Wait. This type of problem we already solved. If you check here, the order means this power, both are same. This power is 1, this power is 1, so these are also same. Okay, so where we solve this type of problem, Cauchy-Euler. If you remember, this is a Cauchy-Euler problem. So what we can do, just maintain r square here, rest all you can multiply. So this r to r will cut and r square will be there. So it will become r del r by r, and it will be minus r lambda. So sorry, this lambda square. Okay, so this is the equation. So in such type of equation, what we have done, if you remember, you have to put small r equal to e to the power z. Okay, so this implies r d by dr you will put as capital D, r square d2 by d r square you will put by d into d minus 1. Okay, so this you have done. So your equation will become of different form. Note down this. You can say this is Cauchy-Euler form. Done?
Yes, sir.
Okay. So put it here. So it will become d into d minus 1 plus d and minus lambda square into r. Now you can take r common outside. That is equal to 0. Okay, so here fd is equal to, now you can multiply it. It will be d square minus d plus d minus lambda square. This is the fd. So this you have to put equal to 0. It will become an auxiliary equation. So d to d cancel. So d square is lambda square. D will be plus minus lambda. Okay. So your solution will be r I need. So that solution will be, because it is in terms of z. Okay. So it will become c1 e to the power lambda z plus c2 e to the power minus lambda z. Now from here, what will be z? Because z I want to convert in r, z will be ln r. So then you put z equal to ln r. It will be c1 e to the power lambda into ln r plus c2 e to the power minus lambda into ln r. So now to get rid of this lambda can be taken as power of that. It will become c1 e to the power ln r to the power lambda plus c2 e to the power ln r to the power minus lambda. So e ln will go. So it will become c1 r to the power lambda and plus c2 r to the power minus lambda. So this is the value of rr. Okay. Similarly, we can do it. We can solve it for phi also. This is your rr. Now another ordinary differential equation. How we can get? You can check the other portion of this equation. This equation. So this equation equal to lambda square will give you the another equation. It is phi double dash by phi. Phi double dash by phi plus lambda square equal to 0. So this phi will be multiplied here. So it will become del 2 phi over del theta square plus phi lambda square plus lambda square phi will be equal to 0. So here you can say that this is del 2 or del theta square plus lambda square into phi is equal to 0. So this will be working as FD. This is a second order differential equation. So we can put here directly 0. So put FD equal to 0. It is your auxiliary equation. So it means d square plus lambda square equal to 0. So d will be plus minus I lambda. So it means your phi theta will be a cos lambda theta plus b sin lambda theta. Hence u r theta is multiplication of both. Means multiplication of r you know c1 r to the power lambda plus c2 r to the power minus lambda into a cos lambda theta plus b sin lambda theta. Now you know how to manipulate it. Now if question come on this basis, so you can use it from directly. Then you can find the boundary condition will be given. You can find the value of a, b, c1, c2 like that. Okay, and you can solve the problem. So you can note down it. This is done or do it. Manjunath, you are from new batch, no? So you will be continuing.
Yes, sir.